Hey, welcome back. Today we're looking at angles and their measures. We're doing part 2 of our lesson today. So today we're looking at the difference between degrees and radians. They measure the same thing, but they're talking about two different ways of looking at two different perspectives. So when we're looking at degree measure, all right, we said that in standard form, we start on the positive x-axis. So that doesn't change. But what an angle is measuring is the amount of change between where we started off with at standard position and how much the ray moved to make our angle. So we're looking at how this ray moved from standard position into the current position where it's at. So that's what we're talking about when we're talking about degrees. Now, Radian Measure also measures an angle, but it measures the angle in a different perspective. So we're still starting off in standard position. But this time when we're talking about it, we're thinking about if this tip of this arrow here was a point, and we rotated this thing all the way around here. That's not a very nice circle, but you get the idea of what it should be. If we're looking at the same angle here, let's draw it in blue. That we created. What Radian Measure is doing is it's measuring how this point moved from standard position to where it's currently at on the circumference of the circle. So we're looking at an arc that was made by the rotation of the ray. It's a little bit different. Just remember radians, the measure is, we're looking at the circumference of the circle, therefore we have pi's involved. Alright, so let's kind of look at this in this way. Oops. So let's say we start in standard position and we go all the way around here to the beginning. That's a terrible circle. Let's do that again. That's a little bit better. All right, so one rotation in degrees, right? For degrees, we start at 0 degrees. If we go all the way around this circle here, oops. If we travel all the way around the circle here in degrees, so we have our ray here and we rotate that thing all the way back to the beginning, that's going to be 360 degrees for one rotation. Right, makes sense. We turn all the way around, that's 360 degrees. We're super familiar with measuring angles, and a complete circle in degrees is going to be 360 degrees. Now, when we measure radians, because we're talking about the circumference of the circle, this same rotation here, we're going to say is going to be 2 pi radians. So 2 pi radians is one rotation. Alright, because, and we get that because we know that the circumference is 2 pi r. Our formula doesn't matter. Doesn't matter what our radius is. It's always in the same ratio. Alright, so that's where we get our 2 pi from. So just remember, one complete rotation is 2 pi, and then you guys will get better at doing it from there. Alright, so let's see how we're going to convert our degrees to radians and vice versa. Alright, so our first task is asking us to convert to radians. So what we need to remember is that 360 degrees is going to be the same thing as 2 pi radians. Oops. 2 pi radians. Alright, so if you guys have done chemistry before, and you remember stoichiometry, what you're trying to do is you're trying to cancel the current units to convert to another unit. So in this case, we have 60 degrees. And we're going to multiply that by Now the only way we're gonna cancel the units is if our degrees is in the denominator. So we're gonna put 360 degrees in the denominator. And we're gonna, oops, sorry, this shouldn't be an R here. And we're gonna put the 2 pi in the numerator. Right, so this degree and this degree cancel out. So we know our answer is no longer gonna be in degrees. That's what we want. We can multiply 60 by 2, which would give us 120 over 360. And then when we reduce, this is going to be pi over 3. All right, so just to recap, we always work with this idea 360 equals 2 pi. So we're just going to write a fraction. We're going to write our 2 pi divided by 360. Here, we're trying to cancel the degrees, right? So the 60 here is going to cancel, the degrees, 60 degrees here is going to cancel with the 360 degrees at the denominator. We're going to go ahead and simplify all the way till we get as simple as possible. All right, so let's try this again. Let's do it for negative 45 degrees. So step 1, again, we're going to start off with our negative 45. We want to cancel the degrees, so we're going to put the 360 in the bottom. We're going to put the 2 pi on top. And we're just going to start simplifying. So negative 45 times 2 is negative 90 pi over 360. The decimals canceled out. The degrees canceled out. And then we can reduce 90 and 360. That'll be 1 pi over 4. And we'll be good. Oops. Okay, last one. This time we have 107 degrees. Same idea, 107. We want it to cancel with the degrees in the bottom. All right, so 107 times 2 is going to give us 214 pi over 360. Unfortunately, this is not going to reduce too nicely, so what they're telling us to do in the book is take our 214 times pi and then divide it by 360. So this gives us approximately, and we're going to use the squiggly lines to say that we're rounding here. Let's round to the nearest thousandth. So 1.868 radians. Okay, so when we're doing radians, if we have the pi, if it comes out to a nice simplified fraction, we'll simplify it best as we can and leave our pi's in there, our symbols in there. Otherwise, we'll go ahead and multiply the pi out to get a decimal. Okay, so that's degrees to radians. Let's check out radians to degrees. Now, if you followed from what we were doing the last time, this stuff shouldn't be that hard. So this time we're doing radians to degrees. We're starting off with pi over 6. We want our pi's to cancel out. We want our radians to cancel out. So we want to end up with just the degree. So we're going to have our degree on top this time. So 360 degrees. And we're going to put our 2 pi on the bottom. Now this works out nicely because our pi's will cancel out. And then we have 360 divided by 6, which is 60 degrees. So first step, we're going to make sure we cancel out our radians. We're doing 360 degrees over 2 pi. We're multiplying it by our original angle, pi over 6. Once the pi's cancel out, we should only have degrees left. So we have 360 degrees divided by 6, and we just do our division and then we're done. Okay, let's try the same idea here. This one's a little bit trickier because there's no pi, which is fine. Sometimes we just have radians without pi's. We're gonna follow the same steps. We want our degrees in the end. So we have our 360 on top. We have our pi on the bottom. We're gonna multiply this whole thing out. So 3 times 360 divided by pi in your calculator. Is gonna give us 343.775. And we're saying approximately because we had to round. Alright, so that's it for today. Good job. Make sure that you've done your notes, you wrote down any questions that you have for class, and I'll see you next time.